Alright. Talk to me already, or? Everybody's supposed to be good today, you know. Uno venture, how is you see? I just move this thing over there. Oh, look at stupidness in that there, yes. That could stay there. I'm really fighting for that so much. So, alright. Assuming everybody ready for some action. Alright, so we test this here. Working good. Alright. So yeah, last live. We look up a good bit of questions. We got some more questions to look up though. We still had to do the probability question from the last live. Look at that here. Yeah, we still had to do the probability question from the last live. So let me continue with that, and then we jumping into. We will do 2013. I again no emails if there were the specimen paper for 2020/2021. Let me know now. All I had to get them thing, cause we are putting up no documents on the screen. You got a copyright strike. What happened to be sold in the channel? So pull up all your paper too. Where my paper 2 is, dear boy? Here. Alright, 2012 paper 2. Number. Yeah, it was number 7 we was on, I think. It's across. Alright, so number 7. A survey carried out in a town revealed that 25% of the household surveyed owned laptop computers and 70% owned a desktop computer. In addition, it was found that 12% owned both a laptop and a desktop. This looking like a little back to basics question here. A little set theory now. So first things first, they want to know if a sample of households from the town is selected at random, determine the proportion that own neither a laptop nor a desktop. So that will just be the complement of, if L represents laptop and D represents desktop, that will be the complement of L union D. So this is number 7. So first things first, let me create some terminologies. Let you be the people in the survey, the set of people in the survey. Let L be the set of people who own laptops. And let D be the set of people who own desktops. Now the question states, so by so is the keys. Well, let me just, I'm putting this on the side here, ready to go fix up this just now. We know that how the number of people who own laptops is 25%. The number of people who own desktops is 70%. We know that how the number of people who own both, so that is L intersect D is 12%. So the best way to illustrate this is on the Venn diagram. Have a universal setup here. Bam bam. Draw with two circles. We do have intersections, so the circles does overlap each other. Copy and paste that one time. Right, so the circles do indeed intersect each other. Let me bring two of them in the middle here now. We know that all this middle piece here is 12%. This is L, this is D. Now the entire of L is 70%. I already have 12% catered for, so 70 minus 12 is 58%. Same thing with D. I already have 12% of the 25% covered, so this fella here will be 13%. Now remember, 100% could be the people in the survey. So L union D, all complement, is equal to 100% take away 58% plus 12% plus 13%. Bring up the calculadora. 58 plus 12 plus 13, take away 100, 17%. So 17% going on the outside of the two sets. So based on the Venn diagram, we can say that how the question asks, determine the proportion that owned neither a laptop nor a desktop. Now proportion, don't give the proportion in terms of a percentage, please. Proportion is in terms of a fraction, or we ratio. 17% owned neither a laptop nor a desktop. So therefore, the proportion, well, I could say this proportion is 17 out of the 100, or you can say 17 to 100, and that's it. Real easy stuff. Yeah, I go send a tennis to fight up yourself. We go organize and we go I'll go email me and I go send it to everybody. Next, a bag contains 4 red marbles, 3 black marbles, and 3 blue marbles. 3 marbles are drawn at random without replacement from the bag. Find the probability that the marbles 1 drawn are all the same color. Alright, no scene. So at the end of the day, if we draw a little diagram for this, right? This was part A. This is part B. Let me draw a little diagram for this. We could draw a bag. Let me say we have the bag here, right? Inside of a bag, the question says we have 4 red, 3 black, and 3 blue. 3 marbles are drawn at random without replacement from the bag. So that means I'm going to take out something from the bag and not putting it back inside. So the first one, if we draw and all are the same color, it's either we can draw and have all, we draw the first one, we get red, draw the second one, we get red, draw the first one, we get red, or we draw first one black, second one black, third one black, first one blue, second one blue, third one blue. So let me see what's going on here. The probability, this is part 1, that all are the same color is equal to the probability that I draw a red, then a red, then a red. Or the probability that I draw a black, then a black, then a black, or the probability that, oh god, blue starting with B as well. Well, let me symbolize blue as another letter. I'll use L. We can use L. L, L, L. But we need to know what L is, so I can say that this is R, this is B, and this is L. So I gotta adjust certain things in my question to cater to the question, right? So the first piece. First, I want to figure out what is the probability that I draw a red marble. Total, we have 4, 5, 6, 7. We have 10 marbles in the bag. The probability that I draw one red could be, well, 1 out of the 10. Yeah? The probability that I draw one red marble, the probability that I draw one red marble could be 4 out of the 10, because I have 4 red marbles in the bag. So the first red, I put an equal sign there. I will do this in my working column. So the first red could be 4 out of 10. The second red. Now remember, when I draw this marble from the bag, I'm not putting it back. So now I have 3 red marbles in the bag, and I have 9 total marbles in the bag. Because if I take out that red, I take out 1 from the red, and I take out 1 from the total at the same time. So if I take out the next red, that will be 3 out of the 9 marbles I have in the bag now. And finally, the third red, again, I no longer have 3, and I no longer have 9. I now have 2 over 8. So that's the first case done. What about the first black? The first black could be, I have 3 black. So the first black will be 3 out of the 10 marbles. The second black will be 2 out of the 9 marbles. And the third black will be 1 out of the 1 out of the 8 marbles. And finally, the first blue is the same thing as the first black, because we have 3 marbles inside of there for blue and black. Second L could be 2 over 9, and the third L could be 1 over 8. Now, in probability, we need to know what is multiply and what is add. Or means multiply. So, the probability that I draw all of the same color for the red would be 4 over 10 multiplied by 3 over 9 multiplied by 2 over 8. So the probability that we have all red will be equal to 4 over 9 by, 4 over 10 by 3 over 9 by 2 over 8. The probability that we have all black, again, is a multiplication. Let's bracket that side for. It could be 3 out of the 10 by 2 out of the 9 by 1 out of the 8. And the probability that we have all blue could be 3 out of the 10, 2 out of the 9, and 1 out of the 8. We'll jump on the calculator. 4 over 10 multiplied by 3 over 9 multiplied by 2 over 8, 1 over 30. 3 over 10 by 2 over 9 by 1 over 8, 1 over 132, or I put 3 over 11. 3 over 10 by 2 over 9 by 1 over 8. 1 out of 120. And it's the same thing for the blue. So here, the probability that all are red will be 1 out of 30. or probability that all are blue is 1 out of 120, or the probability that all are black and then blue is 1 out of the 120. So the probability that all are the same color, when you combine all three of them, we have to add them now. So 1 over 30 plus 1 over 120 plus 1 over 120 is 1 over 20. So the probability that all are the same color is 1 out of 30 plus 1 out of 120 plus 1 out of 120, and that is equal to 1 out of 20. A little side note here, and means multiply, or means to add. Find the probability that the marbles contains exactly one red marble. So let me analyze this one again here. This is part 2, right? Part 1, part 2. If when I pick, and I want to find the probability that I pick one red marble, I can dip my hand in the bag, I can pick a red, and then my next two marbles, they cannot be red. I could dip my hand in the bag, I could pick a black, then I pick a blue, and then the last one have to be a red. So at the end of the day, one of the marbles, we know this probability. We know that it would have to be a red. So the probability that we have one red marble will be equal to the probability that we have a red and not red and not red, because it can either be a blue or a black. Well, remember, and means multiply and or means to add. So the probability that I will pick a red marble, we have that on top there. That is 4 out of 10. And the probability that it is not a red marble, we have black and blue to pick from. So if you think about it, I'm picking one marble out of the black and blue marbles, but I already picked one marble, so it will be 3 plus 3. So I'll put the 3 plus 3 to symbolize the black and the blue, over, I already picked a red marble, so now I have 9 marbles to pick from. Multiplied by, the next one is also not a red. I done pick 2 marbles, so I know the total amount of marbles here will be 8. But I pick another marble from the bag, which is either a black or a blue. So that means I have 1 less black or 1 less blue marble. So I just need a minus 1 from the 3 plus 3. This minus 1 could cater for either picking a blue or picking a black. That could be 4 out of 10 multiplied by 3 and 3, 6 out of 9 multiplied by 3 and 3, 6, 6 minus 1 is 5 out of 8. Check and see what that is. 4 out of 10 by 6 out of 9 by 5 out of 8, and we get 1/6. Cool, man. Looking good. Alright, so this probability question so far, it wasn't that bad. Alright, so we had no statistics question here then. Alright, not bad. So let me go on then. My camera, I think, showing good, right? Nice. Mini game. Next, we have The probability of hiring a taxi from a garage A, B, or C is so by so, so by so, and so by so. The probability that the taxi ordered will be late from A. The probability that the taxi ordered will be late from A is 0.07. Now pay attention to your decimal points, right? I made this mistake in one of my classes and I forgot to correct it. Late is 0.07. In one of my classes, for those of y'all who were there for the past paper classes, I had 0.7. Calculations will be the same, but number will be different. Right? The probability that a taxi ordered will be late from B is 0.1 and from C is 0.2. Illustrate this information on a tree diagram showing the probability of all branches. Tree diagrams is easy peasy lemon squeezy. So this is part C. Now, I recommend when you're constructing a tree diagram, give yourself enough space. So start in the middle here. We go how we trunk, we middle branch. This will symbolize one of the taxis. We have 3 taxis to deal with. So this will be the next taxi here. And then I will break out from that. And finally, this here will be the last taxi here. And again, I'll go break out from that one already. So this here will be the probability of taxi A. This one will be the probability of taxi B. And this will be the probability of taxi C. And this is the case of hiring a taxi. So let me go. The probability of hiring a taxi from garage A is 0.3. So probability of A is equal to 0.3. The probability of B is 0.5. And the probability of C, move this across a little bit here. The probability of C is equal to 0.2. Now a little way you can double check your branches. When you add up the probabilities vertically in a branch, you're supposed to get 1. So I can double check this here. This is my adding up vertically. For my first branch, I will have 0.3 plus 0.5 plus 0.2 and I get 1. That is an easy way to double check your answer moving forward. The probability that a taxi ordered will be late from A is 0.07. So when I order a taxi from A, it's either the brother man he late or he not late. So again, I'll branch off in a different color to avoid any little confusion. So from here, I'm branching off whether he late or whether he that nice a straight line there, boy. It does happen sometimes. Is either he late or he not late. So the probability that he is late is equal to 0.07. The probability that he is not late, or we can say L complement, but I will write not late, not L, could be 1 minus 0.07. That is not 0.03, yeah? 1 minus 0.07. 1 minus 0.07. 0.93. A lot of times students will be like, well, you know, 0.7 add a minus 1 from that and I get 0.3. Be careful. Same thing for B now. We have the probability that a taxi will be late, and then the probability that a taxi will be not late. Let me just extend this line a little bit here, so good. So the probability that a taxi is late from B is 0.1, and the probability that a taxi is not late, this one will be 0.9. And finally, from C, we have late and we have not late. So let me see if I can grab these two here. Nice. Work with that one. So the probability that a taxi is late from C is 0.2. So the probability that brother man is late is 0.2. And the probability that he's not late is 0.8. Very, very simple. Now, again, we can double check these branches of the tree diagram. This is the second branch, which is the orange branch. So we add up all the probabilities on the orange branch, and we're supposed to get 1. So for the first orange branch, 0.7 plus 0.93, I get 1. The next orange branch, 0.1 and 0.9, I get 1. And the last orange branch, 0.2 and 0.8, I get back 1. So that's part 1. Part 2. A garage is chosen at random. Determine the probability that the taxi will arrive late. Alright. So based on the tree diagram, if I pick a taxi, what is the probability that it will arrive late? Well, for it to arrive late, he must either come from A and be late, come from B and be late, or come from C and be late. Remember, we're choosing one taxi, right? Or garage, sorry. So the probability that a taxi is late will be the probability that he is from garage A and he is late, or the probability that he comes from garage B and he is late, or the probability that he comes from garage C and he is late. Remember, and is multiply, go back up here, and is multiply, or is plus. So the probability that A and late will be the probability of A multiplied by the probability that he is late, 0.07, plus B and late could be 0.5 from B and 0.1 for him being late, plus the probability that he is from C and he is late, 0.2 by 0.2. 0.2 by 0.2. Jump on me handy dandy calculator. 0.3 by 0.07 plus 0.5 by 0.1 plus 0.2 by 0.2. 0.111. That's the probability that a taxi will be late. Cool. Part 3. Part 3 states, no, 2 part A and B. Jesus Christ. Alright. So that is 2 part A and 2 part B. A taxi will come from garage C given that it is late. Alright, so this is conditional probability. So the probability that a taxi comes from C given that it is late will be C given that it is late. Okay, good. So this will be the probability that a taxi comes from C given that he is late. This could be the probability of C intersect L over the probability of C. There's a formula you're going to learn. C intersect L is C and L. Sorry, probability is L. Is C and L, which is 0.2 by 0.2, over the probability that a taxi is late will be 0.111 because we worked that out just now. .2 by 0.2 divided by 0.111. Jesus Christ, 0.360360360. So let me leave this as 0.2 by 0.2, 0.04 over 0.111. I'll move this 1, 2, 3, 1, 2, 3. 40 over 111. Yeah, not bad. Number 8. My second day. Alright, Sammy, you would. You there, Sammy? No. It's pretty good. People jump in. I'll put back up and past papers here now. Alright, kinematics. A car starting from rest at a point A. So first things first, I see in some information I can take out from the question here. A car starting from rest. So I know at rest, time is 0, velocity is 0, acceleration is 0. Moves along a straight line. So, I mean, let me write down my information now. At A, the time is 0, velocity is 0, acceleration is 0, distance is 0. Moves along a straight line, reaching a velocity of 24 meters per second by a constant acceleration of 6 meters per second squared. The car maintains this constant velocity of 24 meters per second for 5 seconds and is then brought to rest again by a constant acceleration of -3. Using the graph sheet provided, draw a velocity time graph to illustrate the motion of the car. I don't have a graph sheet, so I go just do a quick sketch. Now for velocity time graphs, we have no negative axis. So there, extend that y-axis all the way. My suggestion is to flip your graph paper landscape, and your x-axis could be the shorter axis and your y-axis could be the longer axis. Label your axes. This is velocity in meters per second, and this fella is time in seconds. So for the first part of the journey, brother man move with constant acceleration until he reached 24 meters per second. Alright, so we start at rest. We're going up the road until he reach at 24. So this fella here could be a little 24. And we need to figure out what the time is because it didn't give you a time. So luckily, we have some formulas that we need to know. I know the acceleration of this line here is 6. I know the velocity and I know the initial time. Well, we have all the equations of motion. So the equation of motion I'll use here. Let me write down all the equations of motion now. V is equal to u plus at. V squared is u squared plus 1/2 at plus 2a, sorry. And the last one, s is equal to ut plus 1/2 at squared. So in kinematics, we either use this information or we use calculus information in the questions. So which one do you think we could use here? I have acceleration and I have velocity. I want to know what the time is. So well, to me, it's looking like I could use the first one. V is equal to u plus at. I have the final velocity, I have the initial velocity, and I have the acceleration. So I'm gonna call it from O to A. Let the diagram be so by so. So I'm saying from O to A, V is equal to U plus AT, my final velocity, my initial velocity, plus 6t. So 24 divided by 6 is 4. So t is equal to 4. So this is 4 seconds here. Next, the question said that how this vehicle maintained a constant velocity for 5 seconds. So I remain at constant velocity for 5 seconds. So that will be u here. So this fella here will be 9. We call this one B. And is brought to rest by a deceleration of -3. Alright, so we come to rest by a deceleration of -3. Alright, we believe that's it. And this could be C here. So again, for BC, I need to figure out what this time is. So again, V is equal to U plus AT. BC, V is equal to U plus AT. My final velocity is 0. My initial velocity is 24. My acceleration is -3 t. 24 goes across. I'm moving the 3t across, make life easy. And t is equal to 8. Now from B to C, my time is 8. So this here will be 9 plus 8, which is 17. So my acceleration here is -3 meters per second. My acceleration here is 0 meters per second because there was no change in velocity. Oh god. Now let's write over the acceleration for the first part here. My acceleration is 6 meters per second. Right? Pretty straightforward. Cool. That is part A, part 1. A, part 2. Determine the total distance traveled by the car. Well, I could say this is A1, A2, and A3. If you want to label it as A1 and A2, and you can say that one of them is a trapezium, big up yourself. So the total distance traveled is the area under the graph. Which is the area of A1 plus the area of A2 plus the area of A3. Area of A1 is 1/2 base 4 by perpendicular height. Area of A2 is 5 by 24. And area of A3 is 1/2 base, that will be 8 by the perpendicular height, which is 24. Four by 24 by 0.5 plus 5 by 24 do that over 4 by 24 by 0.5 plus 5 by 24 plus 8 by 24 by 0.5, 264 meters. That will be the total distance traveled. Right. A second car moving at constant velocity of 32 meters per second drives past point A 3 seconds after the first car left point A. No, sorry, meters per second squared. Thanks, Shane. Good looks. Cool. All right. Now this is a tricky piece of question here, right? Calculate the length of time after the first car started that the second car meets it. Now I could just go back to one of my classes here. 2012 paper 2 number 8. And let me explain this over for you using these calculations here. And then we go discuss it further and do the calculations again. If the second car drives past point A 3 seconds after the first car left point A, that means the second car is 3 seconds behind the first car. Calculate the length of time after the first car started that the second car meets it. Now, in order for both of them to meet, their distances will be the same. Regardless how fast you drive, their distances will be the same. So the first car will have a distance of 48 because that's the distance of the first portion of the graph, plus, again, distance by time. If I represent the time that they meet as t, then the distance will be t minus 4 for the first car with respect to the graph. Do I have a graph here? Yes, I do. Let me say this is the second car here. I'm just illustrating the second car traveling at a velocity of 32 meters per second. Both of them will intersect at some time t. Now for the first portion of the graph here, the distance traveled by the first car will be the area under the graph, which will be the area of the triangle plus the area of this rectangle here, where this is time t. So this triangle, we know how to calculate the area. This rectangle here, 24 multiplied by t minus 4 for my distance, for my length, sorry. The area under the second graph will be t minus 3 because the second car is 3 seconds behind the first car, multiplied by the 32 to get this area here. And both of these distances will be the same. So 32 by t minus 3, equate them and I'll get my time. Now it's a little troubling concept to wrap around, but with the practice, hopefully you all will see it clearly. Down here. Just give it a second, let it load. So again, I'm going to incorporate the velocity of the second car into my diagram. So I'm going to represent that in a blue. So the second car traveling at a velocity of 32 meters per second. At some point in time, these two cars will touch each other. They will reach the same distance. So I just represented that by a horizontal line. Let me say both of them meet each other when time is t seconds. Well, this time up here will always be t minus 3. Because the second car is 3 seconds behind the first car. So we can say that. We go right down with little statements here. So we can say that out. This is part 3. Both cars will meet when their distances are the same. Janice, yeah, we will go over the specimen paper after this, right? I just want to make sure everybody have the specimen paper before we actually do it. So if you don't have the specimen paper, I need you to say so in the chat so we can organize for it to get the specimen paper, because I'm not sharing that on the screen. Both cars will meet when the distances are the same. Let me say, let's say car A and car B Alright, so I'll just represent it as first car and second car. Actually, distance of first car, distance for first car will be the area underneath the graph, which will be A1 plus A2. It will be piece of A2, which will be, first go back up. Piece of A2 will be 24 multiplied by t minus 4. A1 is 48, I think. Yeah, A1 is 48 plus 24 into t minus 4. I'll leave it like that for now. The distance for the second car is equal to t minus 3, 32 into t minus 3. I'll leave that so for now. All we have to say is let both distances be equal to each other. So 48 plus 24 into t minus 4 be equal to 32 into t minus 3. Expand, move around, solve. 48 plus 24 t. 24 by 4 is what way? 96 minus 96 is 32t, and 32 by 3 is what way? 96 as well. 96. The 96 cancels out, so I get 48 is equal to 32t minus 24t. 48 is equal to, where's that way? 32 minus 24, 8, and t is equal to 6 seconds. So when t is equal to 6, both cars meet, and you can see that how when t is 6, that is actually between 4 and 9. Part B now. Hey, look, they actually give the hint there. Assume that the cars meet during the time when the first car is moving at constant velocity. So they do meet between B and C. I mean A and B. They do meet between that. Alright, so part B. A particle moves in a straight line with acceleration a given by 5t minus 1 meters per second squared at any time t seconds. When t is equal to 2, the particle has a velocity of 4. Okay. When t is equal to 2 seconds, the velocity is equal to 4 meters per second. And when t is equal to 2 seconds, the displacement s is equal to 8 meters. Determine its velocity when t is equal to 4. Now, by now, everybody should know the little acronym SVA, S-V-A. If you don't know, now is your chance to know. SVA. S represents displacement, V represents velocity, and A represents acceleration. I'm differentiating going down with respect to t, and I'm integrating going up with respect to t. For example, if I have S and I want velocity, I must differentiate S to get velocity. If I have velocity and I want acceleration, I must differentiate velocity to get acceleration. If I have acceleration and I want velocity, I must integrate acceleration to get velocity, and so on. So for this one here, we want part A. We want its velocity when t is equal to 4. So I want velocity and I have acceleration, so I have to integrate. So velocity, put the black This is part 1, right? Part 1, velocity is equal to the integral of acceleration with respect to time, which is equal to the integral of 5t minus 1 with respect to time. That is 5t squared over 2 minus t plus c, where c is a constant. We have the conditions to calculate the value of the constant. We know that how when t is equal to 2, v is equal to 4. 4 is equal to 5 into 2 squared over 2 minus 2 plus c. Move everything across. 4 plus 2 minus 5 into 2 squared over 2 is equal to c. If you want to calculate it one time, you could go ahead and do so. You don't have to follow my exact methodology. 6 take away 5 into 2, because the 2 cancel on the below, minus 4. Now, right, so t is equal to minus 4, boy. Minus 4. So my velocity is equal to, wait a second, so v is equal to 5 over 2 t squared minus t minus 4. So when t is equal to 4, my velocity is 5 into 4 squared over 2 minus 4 minus 4. 5 into 4 squared divided by 2. That is 40 minus 4 minus 4 is 2 meters per second. Part 2. Its displacement from O, when t is equal to 3. So the displacement from O when t is equal to 3, O is at rest. From O is a fixed point. Alright then, no scene. So S is the integral of v with respect to t. Now you can use the limits if you want, where the upper limit is 3 and the lower limit is 0, assuming that the fixed point has a time 0. Let me go ahead and integrate it here. S is equal to the integral between 3 and 0 of v, which is 5 over 2 t squared minus t minus 4 with respect to t. That is equal to 5t cubed over 2 into 3 minus t squared over 2 minus 4t evaluated at 3 and 0. I know it's just the upper limit, I got how to substitute, but I still want to show it. 5 into 3 cubed over 6 minus 3 squared over 2 minus 4 into 3. Take away 0. 5 into 3 cubed divided by 6. Take away 9 on 2. Take away 12. 6 meters. Not looking. Oh shoot. Okay, hard luck stay people. I make a mistake. We don't want that interval. Alright? We want the distance, the displacement from 0 to when t is equal to 3. Right? It's not an interval. When t is equal to 3. So my mistake. So we don't have no limits here. I could leave the integral there now. Right, yeah. So we don't have no limits. Plus value c, so I'll use a different constant k, but k is a constant. The next condition is when t is equal to 2, s is equal to 8. So we have 8 is equal to 5 into 2 cubed over 6 minus 2 squared over 2 minus 4 into 2 plus k. Move everything across. I can move everything across on my calculator. I have 8 plus 8 plus 2 to the 4 over 2 is 2. Take away 5 into 2 cubed over 6. 11 and a third. So k is 11 and a third. So s is equal to 5t cubed over 6 minus t squared over 2 minus 4t plus 11. We have an improper fraction, so that is 33 and 1 is 34 over 3. Now we can say when t is equal to 3, s is equal to 5 into 3 cubed over 6 minus 3 squared over 2 minus 4 into 3 plus 34 over 3. 5 into, we actually had 6. This was 6, right? This whole thing here was 6. So it could just be 6 plus 34 over 3. 17 and a third meters. Alright, so you just gotta be careful with the little terminology. Right? Yeah, I had the paper. Page 83 is the paper. So let us just load up a little bit there. Add page. So this could be the specimen paper, right? MEN? Yeah. 2020/2021. Right, I'm gonna get here. Just give me a second. Alright, I'm going to assume everybody have it, given that nobody asked for it. Where's paper 1 for the specimen paper? You're doing paper 1 and paper 2, eh? Right. Paper 1. Right, I want to know if everybody there with me with respect to the paper. And all the paper could come similar to this, eh? Real similar. Aidan, you need the specimen paper. Alright, Aidan. Message me. For those of y'all who need the specimen paper, message me. Just message me your name and tell me you need the specimen paper and I'll go send it to you one time. Hustle up. Alright, I could fix this here now. While we wait now. Will it be simple though? Well, yeah, we go see what is in. Me know how difficult it is yet. Me watch the specimen papers yet. So look, nice. Right, I see a man message me there. Next man message me there. Alright, I'm gonna send all of them thing now. Real quick. We're doing paper 1 and then paper 2, right? Oh, it's just one man alone. I'm gonna rename this here. Alright, Shane. Alright, so Shane get through there. Alright, specimen paper for you too. You get through there. Alright, so I'm gonna start one time. If you need it, let me know. The specimen paper is on page 70 of the document. Page 70 is where we're starting at. That is where the paper 1 starts. So see it, please. Send it. Message me, Yanis. Jesus Christ. You go get. I'm gonna look up in your chat. Message me. I'll go get quick. I should leave this pinned on the screen here, right? Palm shot. I'll leave that up there. Nice. We do paper 1 first, eh? That is new and improved syllabus. A studying, I can just cut it across and bring it across, you know. Let me do that. Yes, the same thing we did the other day. I will just cut across the questions and bring them across in the document as we do them now. Alright. I'm going to change back this here, so by so. Good. Given that f of x is equal to so by so and x minus 2 is a factor of f of x, then k, this is the exact same format of number 1 we did in the previous paper. So we have f of x over x minus 2 is equal to f of 2, which is equal to 0 because they say x minus 2 is a factor. So 2 cubed plus 2 into 2 squared minus 5 into 2 plus k is equal to 0. 8 plus 8 minus 10. 8 and 8 is 16. 16 minus 10 is 6. Sorry, plus k. So I have k is equal to minus 6. Move it across. Tralalala is equal to, that is a L, that is a L. So we have Lm plus Ln minus Lm minus Mn. So Lm minus Lm is 0, Ln minus Mn, n into L minus M. N into L minus M. This one here, I just had to take your time. I can see how people will get trouble with this because, I mean, if you like to talk out your work like me, L, N, and M kind of sound a little similar, so you might get a little, your tongue might tie up a little bit when you're doing this question. Just take your time. Yes, you're allowed a calculator in Add Maths paper 1, not in Mathematics paper 1. Right? I think the instructions are there, you know. Yeah, the instructions are there. You may use silent, non-programmable calculators to answer items. So, see how important it is to read all the instructions. Real important to read instructions in the place here. Given that by completing the square, f of x can be expressed as, alright, so this is how I'm going to show a little cheat. Everybody here is supposed to be good at expanding brackets because he's an Add Maths student now. So what I'm going to do, A, B, C, or D, one of these things is equal to 5 minus 8x minus 2x squared. I want to know which one will give me minus 2x squared. Well, which one could give me minus 2x squared? Alright, either one of B, C, or D could give me minus 2x squared. Which one could give me minus 5 as my number? So I'm working out here. Minus 5 will come from what? This could be, looking at part B. Let me expand each one now. 4 minus 2 into x minus 2 squared. I'm going to expand this out. 4 minus 2 into x squared minus 4x plus 4. I get my minus 2x squared, and I get minus 2 by 4 is minus 8. 4 minus 8, negative. I again a minus 5b. C, 3 minus 2 into x plus 2 squared. 3 minus 2 into x squared plus 4x plus 4. I get my minus 2x. I get my minus 8x. 4 2s are 8. And 3 minus 8 is minus 5. So this is the answer, C. The nature of the roots given of a given quadratic equation is described as real and distinct, means that real and distinct b squared minus 4ac is greater than 0. If alpha and beta are the roots of the equation, then the value of alpha, okay, alpha over beta plus beta over alpha, this could be alpha squared plus beta squared all over alpha beta, alpha plus beta squared minus 2 alpha beta all over alpha beta. So I want to know what alpha plus beta is. That is minus b over a. That will be minus 4 over 3. That is 4 over 3. And alpha beta is c over a, which is 1 over 3. Substitute them things up in top now. That will be alpha plus beta. That is 4 over 3 squared minus 2 into 1/3 all over 1/3. 4 over 3 squared, that is 16 over 9. Take away 2/3 divided by 1/3. 3 1/3 or 10 over 3. 10 over 3. A. The range of values for which so by so is less than so by so is, solve it, 2x squared minus 5x plus 3 will be less than 0, putting it equal to 0. For those of you who have this calculator here, it's easy to solve a quadratic if you don't know by now. This version 506TS, you can solve a quadratic here. Mode 2, A is 2, B is minus 5, and C is 3. So 1.5 and 1. So x is 1.5, or x is 1. Checking that on my number line, breaking up my number line into 3 parts. There's 1, 1.5. I'm testing 0. 0 is in section 1, 2, and 3. I just testing 0. When I test 0 here, in the inequality, I get 3 is less than 0. That ain't making no sense. So 2 is satisfied. So it will be 1 is less than x, which is less than 1.5. 1 is less than x, which is less than 1, and with 3 and 2. Nah man, something wrong there. I solved this properly. A is 2, B is minus 5, and C is 3. Right, 1.5 minus 3. That's right. Alright, so even you see how I did make my silly mistakes and all, everybody. So 3 and negative 0.5. Negative a half and 3. Minus a half and 3. Minus a half and 3. So I'm testing 0. So we just now tested 0. 0 didn't make any sense. 0 is in section 2. So the answer will be 1 and 3, which is x is less than minus a half union x is greater than 3. X is greater than 3. X is less than minus a half oh no, 2 will be satisfied because I changed it, sorry. Whew. Right, because yeah, minus 3 is, so 2 is satisfied. So the answer will still be minus a half is less than x is less than 3. A. Again, if all you need me to do my method of solving these things, I'll go do it, put a video on it, let me know. Alright, so for multiple choice, what you can do for this thing here, for multiple choice, put the numerator greater than 0, put the denominator greater than 0, and solve for the two values. Put them on the number line and test. So I know that my two values for this number line here are going to be 3 over 2 and minus 1. I'm testing 0. When I plug in 0 into my inequality, I get 2 into 0, I get minus 3 over 1. Minus 3 over 1 is not greater than 0. 0 here. So therefore, again, well, in this case 1 and 3 is satisfied. So x is less than 1 and x is greater than 3 over 2. See. This is supposed to be and though. I don't like this or, it's not or. Alright, let me go and bring across the next page. Tomorrow class could be during the day, it wouldn't be in the evening time. Given that so by so, let me see if I could fit this a little lower here. Yeah man, I could drop it a little lower. And I could flick this up here. Tighten this here a little more. Rock this around so. Nice man. That working a little better for me too. I could see the screen. Cool. Right. 2 by, that is x to the power quarter. Let me just check. I mean 4 to the power x. Oh good lord. Yeah, that is 4 to the power x plus 1 on that power there. So 2 multiplied by 4 to the power x plus 1 is 16 to the power of 2x. 2 multiplied by 2 squared to the power x plus 1 is 2 to the power 4 to the power 2x. That is 2 to the power 1 plus 2x plus 2 is 2 to the power 8x. Equate them. 3 plus 2x is equal to 8x. 8x minus 2x is equal to 6x. X is equal to 3 over 6, which is a half. Which one you guys see for Navindra? Remember, other answers is coming a little later than when I do the questions. So you let me know, like, you can see for which one, number 9, number 8, number 7, you know. Alright, number 12, number 10. Given that is the value of x is, so we have some logs here, right? What you could do, you could actually plug in all the values into the equation and check and see where you get. Same thing for number 9, but I like to solve it. Be sure. 3 to the power x squared is 14 to the power 2. Well, this 3 to the power 2x is equal to 14 to the power 2. Well, we could take ln or lg. ln 3 to the power 2x is ln 14 squared. 2x ln 3 is 2 ln 14. X is equal to 2 ln 14 over 2 ln 3. So we have ln 14 over ln 3, or we can have log 14 over log 3. So the answer is B. Number 9, you check wrong. Number 9 is D. You can check it over. I don't think I make a mistake. Let me check it over and see. 2 multiplied by 4 to the power a half plus 1 is equal to 5, and 16 to the power of 2 by a half I get 16, so a half is not the answer. What we get here? There's 1, yeah, 2 to the power 2, 16 to the 4 to the 8x, right? 1 and 2 is 3, yeah? 3 over 6 is a half. Let me do it over and see. There's 2 multiplied by 2 squared to the power x plus 1 is 2 to the power 4. 2 to the 4 to the 8 to the 16, yeah? 2 to the power 4 to the power 2x. 2 to the power 1 multiplied by 2 to the power 2x plus 2 is 2 to the power 4 to the 8x, right? 1 plus 2x plus 2 is 8x. 2 and 1 is 3. 8 minus 2 is 6. Yeah? 3 over 6 is equal to x. X is a half. Yeah, x is a half. Let me check it over again. I don't think I can make the same mistake twice. It's possible. 2 by 4 to the power, open bracket, 0.5 plus 1. Yeah, 16. Alright, so I checked the first side wrong then. Answer is, yeah, the answer is D. the value of log of 8 to base 4 minus log of 2 to base 4 plus log of 1 on 16 to base 4 is, you don't even have to go and plug in anything in a calculator. If your calculator could work in different bases, the Casio doesn't. It have some Texas Instruments that can work in different bases. Plug it in now and see what you get. But for those of you who can't do that, we have to change it up a little bit. So here we go have log of 2 to the power 3 to base 4. Actually, we don't have to do that. All the bases are at the base 4. So we can use the laws, law 1 and law 2. Addition and subtraction. This could be log of 8 divided by 2 multiplied by 1 over 16. Bam, bam. 2, we get log of 4 a quarter to base 4. That will be log of 4 to the minus 1 to base 4, which is minus 1. A. That, when simplified, is equal to, I know it can be minus 1, I know it can be 1. It either had to be root 3 plus 2 over 2 or root 3 plus 2. So what I'm going to do, for those of you who know how to use the storage function in your calculators, this could be very, very beneficial. 1 plus root 3 equal, divided by root 3 minus 1. Make sure you put that in a bracket. Root 3 minus 1. I get this here. Storing that in A. So A is the full value of my question. So if I take that away from C, I suppose I get 0 if C is the same thing. Well, root 3 plus 2 divided by 2, take away from A. If I get 0, then C is the answer. I get 0, so the answer is D. And I'll show you. D is root 3 plus 2. Root 3 plus 2. Take away A. Suppose I get 0. I get 0. D. The value of this is, okay, we have summations and Papa, you teach my fellow this. Right, so for those of you who was under me, we go have a class to deal up with summations, right? This is actually a, let me check it out and see, right? This could take the form of an AP. So what shall we gonna do? If I show you one, I'll show you all. The summation is an R. Just check and see. R is equal to 1 to 20 of 3R minus 1. I calculate my first term. T1 is when R is 1, which will be 3 into 1 minus 1. 3 minus 1 is 2. T2 is when R is equal to 2. 3 into 2 minus 1. 3 2s are 6. 6 minus 1 is 5. T3 is equal to 3 minus 1. 3 3s are 6. 3 3s are 9. 9 minus 1 is 8. So I can see we forming an AP here with first term 2, common difference 3. So A is 2 and D is 3. I want the sum of the first 20 terms in this AP. S20 is equal to N over 2 into A plus L. We can calculate the last term in this case. The last term is when R is 20. So that will be T20 will be 3 into 20 minus 1. That will be 60 minus 1 is 59. That could be 10 into 2 plus 59. 59, 60, 61, 610. B. The first term of a GP is 16. Okay, first term is 16. The fifth term is 81. Given that the common ratio is positive, the value of the fourth term is, okay, well, we know that our T sub n is equal to AR to the n minus 1. T5 is equal to 16R to the power 4. This is equal to 81. So r to the 4, 16, r to the 4 is 81. R to the 4 is 81 over 16. Find the fourth root of this. The fourth root of 81 is 3. The fourth root of 16 is 2. R is positive. Positive 3 of it. Oh, we already have the value of the fourth term. Cool. R is that. So T4 is equal to AR cubed. That is 16. 3 over 2 cubed. 16 into 3 over 2 cubed. 54. Sum to infinity is a over 1 minus r, given that the modulus of r is less than 1. A, 81 over 1 minus r. R will be 27 over 81, or make life easy, 3 over 9, which is a third. 81 over 2 thirds is 81 divided by 2 thirds. 243 over 2, or 121.5. See. Let me pull the next one there. If I have any questions, I always message me as well, right? If I reply, I respond, I answer. If me I respond, then no me ready, or no me really in the mood or something. So just to message me all 11 o'clock in the night and thing. Because I'm like my sleep. The coordinates of the points A and B are so by so and so by so. The perpendicular bisector to the line AB is given by the equation. Alright, so first things first, I'll go in and check the gradient of each of the answers and see if all of them are different. So the gradient of the first one, when I move the x across, I'll get the gradient is 1/6. I move the x as minus. I'll move the x. Okay, so it has some gradients here that are the same thing. So what are we going to do? Is there more than one way you can approach this? Either calculate the midpoint of AB and substitute those points into the equation, see which one satisfies the equation, calculate the gradient of AB, and see, well, by calculating the gradient of AB, you can also get the gradient of the perpendicular bisector of AB. Check and see which gradients line up, or you can actually go and do the whole question. I say let me do the whole question, right? So we have A is 2 minus 3, B is minus 10 minus 5. Now, I'll leave out plenty statements here, right? Please don't do this for paper 2. Because it's paper 1, I can leave out plenty statements. x1, y1, x2, y2. The gradient is equal to y2 minus y1 over x2 minus x1. That is minus 5 plus 3 over minus 12. Minus 5 and 3 is minus 2 over minus 12, which is 1 over 6. So the gradient of the perpendicular bisector could be minus 6. The midpoint of AB, x1 plus x2 over 2, y1 plus y2 over 2. 2 minus 10 is minus 8, minus 8 over 2 is minus 4, minus 3 minus 5 is minus 8, minus 8 over 2 is minus 4. So minus 4 is the point we're using. So the equation of the perpendicular bisector is y minus y1 is equal to m into x minus x1. Y is equal to minus 6x, that will be plus minus 24 minus 4. Y is equal to 6x minus 28. bring everything on one side. Y plus 6x plus 28 is equal to 0. Y plus 6x plus 28 is equal to 0. B. Now the next way we could do this is the gradient of the perpendicular bisector is negative 6. So I'm going to check each one of these here and see which one will give me a gradient of negative 6. It just so happens that B and D will give me a gradient of negative 6. It is not enough information. So we need to calculate the, check and see if the midpoint actually satisfies B or D, and you'll get an answer. The lines 2y minus 3x minus 13 and that intersect the point of P, the coordinates of P are, again, just substitute each one of these points into the equations and see which one satisfies the equation. If I substitute 3 and 2, I will get 3 plus 2 plus 1 are wrong. Substituting 3 and minus 2, I get 3 minus 2 plus 1 is equal to, well, this one here is not equal to 0. 3 minus 2 is 1. This is not equal to 0, so this one is wrong. Next one, minus 3 and minus 2. Minus 3 minus 2 plus 1. This is not equal to 0, so this is wrong. Lastly, minus 3 plus 2 plus 1. This is equal to 0, so this is correct. Alright, so radius equation of a circle is given by so. The radius of the circle is, okay, cool. Now this one here is a little different to the form that I use, so I go in and bring this in the form that I accustomed using, which is negative x squared minus 2fx plus y squared minus 2gy plus c is equal to 0. So one time x squared minus 2fx plus y squared minus 2gy plus c, we could leave it as minus 60. Minus 60 is equal to 0. In order to get back 12 here, I need to put a minus 6. And in order to get back 4 here, I need to put a minus 2. So f is minus 6 and g is minus 2. C is minus 60. The radius is the square root of f squared plus g squared minus c. If I remember correctly, f squared plus g squared is not minus c. Yeah, it's minus c. Minus 60. 36 plus, what is that? 4 plus 60. 64 and 36 is 100. Square root of 100 is 10. B. The length of the vector PQ is root 13. Then K is real. Alright, so modulus of P is the square root of 2 squared plus minus k squared. So we have root 13 is square root of P, which is square root of 4 plus k squared. Square both sides. 13 is equal to 4 plus k squared. Move that across. 9 is k squared. K is equal to 3. Plus or minus 3. The value of the real number t for which those two vectors are parallel is if two vectors are parallel, then one can be expressed as a scalar multiple of the other. So in order for me to get this here, A is 4i plus tg and B is 2i minus 3j. So A can be expressed as 2 into 2i plus, I will leave it as tj. It will be t over 2g. I want to express this in terms of this here, right? So I wouldn't go through that. I will go through the long way around. And know that if they are parallel, then A is equal to lambda B. So 4I plus TG is equal to lambda into 2I minus 3G. So 4I is equal to lambda 2I, and TG is equal to minus lambda 3G. I can calculate what lambda is. Lambda is equal to, 4 is equal to 2 lambda. Lambda is equal to 4 divided by 2, which is equal to 2. So T is equal to minus 3 2s are 6. So T is equal to minus 6. The position vectors AB, the acute angle AOB is given by, right, mod A mod B cos theta. So mod A mod B cos theta. A dot B is equal to that. So A dot B over mod A mod B is equal to cosine theta. Let me figure out what mod A mod B is. I dotted my I's and I dotted my J's. 2, 3, dotted with 7, 4. Multiply my I's, 2 by 7, and add it to the product of my J's. 3 by 4. That is 14 plus 12, which is equal to 26. So A dot B is 26. So one time, D is my answer. The trigonometrical expression that is identical to, and to do this one, okay, they give us different answers to choose from this time here. Now one way you can do this, if you don't like trigs, pick an angle for x, work out what the question is for that angle, and check and see which one of the answers it's equal to by substituting that angle. For example, take x equals to 30 degrees. Check 30 degrees 1 plus sine 30 over cos 30 plus cos 30 over 1 plus sine 30, you get that answer, and see which one of the answers that is equal to. So if it's equal to 1, then A is your answer. Check what 2 over cosine of 30 is. If it's equal to that, that's your answer, and so on. Or we can use it by proving it using identities. So we have 1 plus sine x over cosine x plus cosine x over 1 plus sine x. 1 plus sine x squared plus cosine x squared over cosine x into 1 plus sine x. 1 plus 2 sine x plus sine squared x plus cos squared x over cosine x into 1 plus sine x. This is 1. That is 1 plus 2 sine x plus 1 over cosine x into 1 plus sine x. I could factorize it up. 2 into 1 plus sine x over cosine x into 1 plus sine x. Sine x cancels with sine x, we get 2 over cosine x. And that's your answer. I'm going to show you just the shortcut. Make sure you use your brackets properly, right? If you're not comfortable proving it using an identity, do it like this. Let x equal to t. 1 plus sine 30 divided by cosine of 30 is that, plus, putting all this in our bracket, cosine of 30 divided by, actually I will leave that in the bracket, cosine of 30 divided by 1 plus sine of 30, and I want to put this whole thing in our bracket. Please have a good understanding as to how to use your brackets. I get 2.3094. That is not 1. Storing that in A. 2 over cosine of 30. Take away a, suppose you get 0. If that's your answer, we get 0. So that's the answer. If you have any questions on that, feel free to ask. Alright, next. This, we do have a question like this yesterday. This is cos A cos B plus sin A sin B minus cos A cos B minus sin A sin B. I'll show this in a bracket here. So cos A cos B will cancel out, and sin A sin B plus sin A sin B is 2 sin A sin B. Again, you can assign a value for A and a value for B, and check and see which one it's equal to. No problem in that at all. Alright, number 24. Sin theta is that and theta is obtuse. Alright, so draw a triangle, sorry. This theta. Sin theta is opposite over hypotenuse. Just looking like another Pythagorean triplet. You get 8 here. Cosine theta is adjacent over hypotenuse, which is 8 over 17. Theta is obtuse. Obtuse is here, and sine is positive here, so this could be negative 8 over 17. Right, so let me just check and see. 17 squared minus 15 squared is 64, so we get 8 as the adjacent. The smallest positive angle for which that plus cos theta is equal to 0. So again, this is a little change from 2012. In 2012 we had sin theta minus cosine theta. So here we have sin theta is equal to negative cosine theta divided by negative cosine theta. We will get negative tan theta is equal to 1, or we get tan theta is equal to minus 1. I know that our theta, the principal value will be pi on 4. All school teachers, so this is theta is equal to 180, or pi on 2, no, sorry, pi plus pi on 4, so that will be 4 and 1 is 5, 5 pi on 4. So for that, the solutions for the equations exists in quadrants. Alright, so just checking to see. Sine squared theta is equal to a quarter. Sine theta is plus or minus a half. So solutions will lie in all quadrants 1, 2, 3, and 4. Number 27. 2 sine x minus pi on 2 is equal to 2 sine x minus pi on 2. Alright, next compound angle formula. This is 2 into sine x cosine pi on 2 minus cosine x sine pi on 2, 2 sine x, I think cosine pi on 2 is 0, 0, 1, cosine of pi on 2 is negative a half, no, shucks, brackets, please use the brackets. Cosine of pi on 2, pi on 2, use your brackets please, 0, so this first thing turns out to be 0, minus sine of pi on 2, sine of pi on 2 is 1, minus cosine x, so this could be minus 2 cosine x. Again, if you wanted to assign angle, go ahead and assign an angle. Zoom in. Gerald, you're using phone on. From the next paper, I could start making it a little bigger again, right? Cosine of a plus a, like cos a, like cos squared a, minus sine a, like sine squared a. So that is cos squared a minus sine squared a. Oh, there's a double angle formula, right? A plus a is 2a. So cosine of 2a is equal to cos squared a minus sine squared a. Cos squared a is 1 minus sine squared a minus sine squared a. So that is 1 minus 2 sine squared a. So C is the answer. I just want to check over this. Check the next one. Is cos squared a minus 1 minus cos squared a. So it will be 2 cos squared a minus 1. Okay, cool. So C is the answer. Again, if you wanted to put an angle, you could have put an angle. For that, the values of x which satisfies the equation are... Jesus Christ. Okay. I don't want to solve this, so what I will do, I will just substitute values into the equation and see what I get. So I'll go check. First, I'm going to check pi on 6. When x is pi on 6, I'll get 2 cosine of, see this here, 2 cosine of pi on 6 squared plus 3 sine pi on 6. I suppose to get 0 if this is actually a solution. I get 3. So this is not a solution here. So pi on 6 is not a solution. Get up different combinations of solutions here. Alright, well if push comes to shove, let me do it now. I like to cut little corners in paper 1 to finish early. If we can't cut it, we can't cut it, right? So this could be 2 cos squared x plus 3 sine x is equal to 0. Cos squared x is 1 minus sine squared x plus 3 sine x is equal to 0. 2 minus 2 sine squared x plus 3 sine x is equal to 0. Multiply by minus 1 on both sides. 2 sine squared x minus 3 sine x minus 2 is equal to 0. Factorize it. 2 by 2 is minus 4. Minus 4 on 1. 2 sine squared x minus 4 sine x plus sine x minus 2 is equal to 0. 2 sine x into sine x minus 2 plus 1 into sine x minus 2 is equal to 0. Sine x minus 2 into 2 sine x plus 1 is equal to 0. We get sine x is equal to 2. This is out of range. Then we have sine x is equal to minus a half. My principal value is sine inverse the modulus of minus a half, which is sine inverse of a half. I'm using this in degrees. Sine inverse of 0.5 is 30 degrees, that's pi on 6. Sine is negative here and here, so here's pi plus pi on 6, and here's 2 pi minus pi on 6, so that is 6 and 1 is 7 pi on 6, and 12 minus 1 is 11 pi over 6. If all you want me to do any topic in particular, like solving trigonometric equations and teaching it in depth, just let me know in the chat. Alright, I will go ahead and make the video and I'll go put it up so I can get a good practice with it instead of seeing it for a particular question. Because obviously I'm not going to explain things in depth when I'm doing it here. That should be a little bigger there now, so I think I'll zoom in enough there. But after this one, you go take a little 5 now, since 3 o'clock I'm talking. I'll let my voice rest a little bit. Alright. The radius OA is 4 and the angle AOB is pi on 2. The area of the sector AOB. So area of a sector, area is a half r squared theta, which is a half 4 squared pi on 2. I'm leaving it in terms of pi. Half of 16 is 8 and 8 on 2 is 4. So that's 4 pi. You could use the shortcut here. Y is equal to 3x minus 2 cubed. Then dy dx is equal to 3 into 3x minus 2 squared multiplied by 3. We get 9 into 3x minus 2 squared. Given that y is that, then dy dx is, alright, so u is 3x plus 5. So du is 3. And v is 2x minus 11 and dv is 2. So we have dy dx is v du dx minus u dv dx all over v squared. Well, all of them have 2x minus 11 on the denominator. So all I'm going to do is I'm going to see if I can work on the top here. But they have the top in a particular form. Okay, they have the top in the form without expanding it, right? So I'm looking for 2x minus 11 by 3. Alright. Minus 3x plus 5 by 2. So C is the answer. So in a case like that, if I didn't watch the answer, then I was going to expand and simplify it. But because I watched the answer, I see that, oh well, you know, they're looking for the answer in a particular form, so that's how I know not to multiply and expand out something. The curve C is given by the equation, the value of dy dx. So we differentiating again. Dy dx is equal to 3 cosine x. At pi on 3, we have 3 cosine of pi on 3, and pi on 3 is 60 degrees, that's a half, so that is 3 over 2, b. You can check it over if you want. Cosine of pi on 3 is a half multiplied by 3 is 3 on 2. The point P lies on the curve with the equation that the equation of normal to the curve is given by Jesus Christ. This is a good piece of working here, boy. Alright, so y is equal to x into x minus 3 squared. Now this is in the form of a product rule, but I want to make life easy for myself, so I'll just expand it. X into x squared minus 6x plus 9. X cubed minus 6x squared plus 9x. So dy dx is 3x squared minus 12x plus 9. Equation of the normal to the curve at x is equal to 2 dy dx is equal to 3 into 2 squared minus 12 into 2 plus 9. That is 2 2s are 4, 3s are 12, minus 24 plus 9 minus 3. There's a gradient at the normal. There's a gradient at the tangent. So the gradient of the normal is equal to 1/3. The equation of the normal using P which is 2, 2 is y minus y1 is m into x minus x1. So again, if I didn't look at the answers here, I would have gone and expand and rearrange this equation in the form of y is equal to mx plus c. So y minus 2 is equal to 1/3 into x minus 2, 1/3 into x minus 2, c. An object moves in a straight line with a velocity equation given by that. The expression for x, again, SVA, S-V-A. I have velocity and I want acceleration, I had to differentiate. So dv dt is equal to, so first I'm going to write out what v is. V is equal to 2t squared minus 6t plus 18, and the v dt is 4t minus 6. Sorry, 40 minus 12. Okay. The positive value of z for which that is equal to 9 is, so we have the integral of x squared evaluated at z and 0 is equal to 9. So we have x cubed over 3 evaluated at z and 0 is equal to 9. So we have z cubed over 3 is equal to 9. 9 3s are 27. Z cubed is 27 and z is 3. Not bad. And the final hurrah here. Okay, it's not the final hurrah. One more page after this. Right, so I will rename this question here specimen paper 1, right? Specimen paper for this syllabus, the academic year. The indefinite integral is given by 3 sine x minus 2 cos x. So again, I like to write it out. If y is equal to sine x, dy dx is cosine x. So when I integrate cosine x, I get back sine x. And if y is equal to cosine x, dy dx is minus sine x. So when I integrate sine, I get negative cosine x. So when I am integrating this here, the integral of 3 sine x minus 2 cosine x with respect to x. When I integrate sine, I get negative cosine. When I integrate cosine, I get sine plus c. So it have minus 3 cos minus 2 sine. Minus 3 cos minus 2 sine. Good. C is the answer. The finite region R is bounded by the y-axis, the x-axis, and the arc of the curve y is equal to 3 x minus 3 to be squared. As shown in the figure above, the area R in units, in square units, is, well, the area under the curve. That would be the integral of x minus 3 squared evaluated at 3 and 0. I'm going to expand it. I get x squared minus 6x plus 9 between 3 and 0, like x cubed on 3 minus 6x squared over 2 plus 9x evaluated at 3 and 0. So I get 3 cubed over 3 minus 3 into 3 squared plus 9 into 3. Take away 0 because the next integral will be equal to 0. That is 27 over 3. That is 9. Take away 27 plus 27. That is 9. Oh, very, very interesting. The area underneath a curve is a nice whole number 9. Just an interesting question. The velocity of a moving particle from rest is given by that. Again, SVA, SVA. SVA. They give you velocity, the word displacement, so we're going up, so we're integrating. I had to integrate V with respect to t to get S. So S is the integral of 6t squared minus 4t plus 3 with respect to time. 6t cubed over 3 minus 4t squared over 2 plus 3t evaluated at when x is equal to, when t is equal to 3. When t is equal to 3, s is equal to, u goes with u, we get 2 into 3 cubed minus, we get 2 into 2 squared plus 3 into 2. I like to use my calculator. 2 into 3 cubed minus 2 into 2 squared plus 3 into 2, 52. T squared minus 4t plus 3. 60 cubed on 3, 4t squared on 2, 3t. Right, 2 into 3 cubed, right, minus 2 into 2 squared plus 3 into 3. I'll do that over 2 into, oh, I substituted the wrong limit, sorry. 2 into 3 cubed minus 2 into 3 squared plus 3 into 3, 45. My mistake, I substitute t is equal to 2. So this is supposed to be 3, and this is supposed to be 3. Right? My little blunder there. Explain SVA real quick. SVA. So if I have S, this is displacement. This is velocity. And this is acceleration. All three are related by calculus. So the rules say if I have any one of these, I can get any of the others. If I'm going down, I am differentiating with respect to t. And if I'm going up, I'm integrating with respect to t. And I explained this earlier on in the video. So for example, if I have S and I want V, I'm going down, so I have to differentiate. If I have A and I want V, I have to go up, so I have to integrate. So I have to integrate A to get V. I have to differentiate S to get V. I have to differentiate V to get A. I have to integrate V to get S. Alright, so using the shortcut to the product rule here, to the chain rule, sorry. Integral of 2x plus 3 to the power 5. I integrate the normal 2x plus 3 to the power 6 all over 6, and I'm multiplying the denominator by the differential of the bracket, which is 2. Ooh, alright, so it's 1/12. So this is the answer. See. You'll scared this. Alright. The mean number of children per family is, Jesus Christ. So sigma f of x divided by sigma f, number of children, number of families. So let me interpret the table and see if we could work this out using a maths perspective. I don't like to do probability using the Add Maths perspective. It's very complicating. Number of children, number of families. So 9 families have 0 kids. 10 families have 1 child. 20 families have 2 children. 7 families have 3 children. And 2 families have 4 children. The mean number of children per family is, so we multiply these things here, add them up, and divide it by the total number of families. Real sucker thing here. So watch. Let me write it down now. So total number of children is equal to 9 by 0 plus 10 by 1 plus 12 by 2 plus 7 by 3 plus 4 by 2. 9 by 0 plus 10 by 1 plus 12 by 2 plus 7 by 3 plus 2 by 4. That is 10 plus 24 plus 21 plus 8. 10 plus 24 plus 21 plus 8, 63, and divided by the total number of people, total number of families, because per family they wanted 4. 9 plus 10 plus 12 plus 7 plus 2, 40, 63, 40 over 63, 0.63. So they just put it the 2 significant figures. No, like 6.3. Sorry. 63 divided by 40. 1.575. My bad. The total number of families is 40. So the mean is 63 over 40. Buy $1 for $2. That's our investment. Ismail, good job. Your maths teacher would be proud. Guide, box and whisker. Alright, nice small thing. Let me see what you can do here. No, do expect anything too great from probability, right, fellas and ladies? Is not my strong point. The shape of the population, the shape of the distribution of the population data is either symmetrical, positively skewed, or negatively skewed. So this is where I have to do my research. So I'm just going to my notes and let me see about this skewation of data. Give me a second, okay? That will be stats. Box and whisker. Right, if you have any suggestions, put them inside of the chat now. Okay, cool. This one here, it is not symmetrical, it is negatively skewed only. 3 only. So I will just slap in a little diagram here. again, probability is not my strong point, right? The probability of an event occurring is 0.3, and the probability of an event B occurring is 0.6. Given that the two events are independent, then A given B, the probability of A given B is the probability of A intersect B over the probability of B. Given that there are two independent variables, probability of A intersect B is probability of A multiplied by the probability of B over the probability of B, which is 0.6, sorry. Oh, yeah, 0.3. B. Two events C and D are mutually exclusive. Again, if anybody have any other suggestions, let me know, right? Two events C and D are mutually exclusive, given that probability of C is equal to 0.2, the probability of D is 0.3, and C union D is 0.5, then the probability of C intersect D is, so we have a formula, the probability of C union D is the probability of C plus the probability of D minus the probability of C intersect D. So rearrange C union D is 0.5, take away the probability of C, 0.2, take away the probability of D, which is 0.3, is equal to negative probability of C intersect D. That looking like 0 is negative the probability of C intersect D, and 0. In a class of 50 students, 20 students study Chem, 25 students study Physics. It is an exam diagram here. Draw a quick thing. Show me two shapes. Bam, bam. Copy that fella there. Piece in there. Intersect them there. Take up that C. 50 Physics and Chem. 20 students study Chem. 25 students study Physics and 10 study both. 10 study both and 25 study Physics, then there's 15. If 20 study Chem and 10 done day, that the next 10 day. 10 and 10 is 20, 20 and 15 is 35, so the outside will be 15. The probability that students who study neither is 15 out of 50. A. Alright. Cool. So that's specimen paper 1. Alright. So this is what I'm going to do, right? Tomorrow we will do paper 2. Paper 2 for the specimen paper. It could take too long to complete it in the rest of the video. If anybody have any questions, again, my number up here. My number up there. Pick up yourself. Go back and review the video. I'll see if I can start inputting timestamps for the paper 2s. For paper 1, I wouldn't put timestamp. I will try and pass timestamp for when this paper started, so you could just fast forward to it, okay? Alright. Tomorrow, you will subscribe, turn on the notifications, and we will do the paper 2 for the specimen paper tomorrow. I don't know what time as yet. We gotta see. I think tomorrow is finals for some football. Copa, I think, is tomorrow. I think. I'm gonna double check that. We will see what is seen. Yeah, Shane, I know, see, man. Don't fight up yourself. That's what I'm here for. But no, man. Today is bronze final. Tomorrow is finals for Copa. Right. So tomorrow 8 o'clock. That is 8 o'clock in the night, man. So we have time during the day. Alright. On Sunday, 3 o'clock is finals. So we will have class probably in the morning. And Sunday morning. Monday, resuming from 3 o'clock until Tuesday, 3 o'clock until. And again, if anybody needs any help with any topic in particular, I need to know my number there, message me, I will make the video on it, and I go upload it onto YouTube for all you. So I just had to let me know where's the scene. Alright? So I will see everybody tomorrow bright and early. I don't know what time as yet. Just make sure you have the notification bell on, and we're going